Today we are finishing chapter 13. We are still talking about experiments, but we're going to add a couple of new details to experiments. Yesterday we kind of focused on straightforward basic ones that only had one kind of factor to study. We're going to look at multiple factors here and some new vocab. So the best experiments are randomized, which we've talked about, comparative, like the one with the cars where we separated the ones so that it was better to compare. And then we have two new vocab words. The best experiments are also double-blind and what's called placebo-controlled. So let's get into some more new vocab. Blinding. This is a very important vocab word. Let's talk about what it is. Blinding is used to avoid the bias that might result from knowing what treatment was assigned. This is very big with drug studies. When people volunteer to participate in a drug study, you do not want them knowing what drug they are getting because there are mental things that can affect outcomes that we don't realize. So blinding, literally, you're blinding them. You're covering them up. You're covering their eyes. They don't know what they are taking. There are two classes or groups in an experiment. There are those who could influence the results. Those are your subjects that you're studying, the treatment administrators, the people who are giving the treatments, and the technicians, the people who are doing like the measurements. And then there are also those who evaluate the results. Maybe they are judges, maybe they are physicians who are looking at the results of a drug study and making conclusions. To be a single blind experiment, that is when all individuals in one of these groups are blinded. In other words, either the subjects, the administrators, and the technicians, all of those people are blinded and don't know what's going on, or the judges and the treating physicians, those kinds of people, don't know what's going on with the experiment. A double-blind experiment is when everyone in both classes are blinded. The way we accomplish that is having somebody who is running the experiment not involved in the administration or the evaluation. So if you're the one that designed the experiment, you're going to be the one that puts everybody in their groups, but then you have no involvement in giving them drugs and collecting data, and you have no involvement in evaluating that data. You are just the one that set everything up. Now, a placebo, which I'm pretty sure you guys have heard this word before. Placebos are very, very common with drug studies. A placebo is a fake treatment. It looks just like the actual treatment or drug that's being tested. We do this because we need to be able to make sure that everybody thinks they're getting a pill, but nobody knows whether it's a real pill or a fake pill. Typically, placebos are sugar pills. Okay, it's just a sugar, it's just a substance that you swallow just like a regular pill, but there is no actual medicine there. It's just a sugary substance put together to look like a pill. What is the placebo effect? This occurs when taking the fake treatment still results in a change in the response variable. This is the mental side of things. If somebody knows they're taking a pill, sometimes their brain will tell them that, oh, I should be feeling better. That's the placebo effect, because even the people who get the fake sugar pill, they still think they're getting a real pill, so their brain still tells them, oh, you're getting something to help you, you need to get better. So that is unfortunately a natural occurrence that we cannot control. That would be like a confounding variable, something that is completely out of our control. So the rest of this we're going to look at adding in some new pieces to these experiments. So we have an experiment that wants to compare the effectiveness of 3 television commercials for the same product. You decide, though, that women and men respond differently to advertising. So this is important right here. Men and women respond differently to advertising. So we want to create the experimental design using randomized block. Anytime you know something like gender affects the results, that's when we use the blocking again. So we're going to again diagram this experiment using blocking. So we're going to start by blocking out men and women. So you are now in 2 rooms, you are separated. So now, among the men, we are going to randomly separate them into, how many commercials we got? We have 3 commercials. So we are going to randomly break them into 3 groups. So this is random. We're doing group 1, group 2, group 3. We're going to do the same thing with the women. We're going to randomly break them into 3 groups. But this time we're going to call them groups 4, 5, and 6 because we want to make sure that when we give the results to the person analyzing them, that they don't know who are men and who are women. It's just 6 groups. So then, we have to assign each group a commercial. So we're going to do commercial 1 here, commercial 2 here, and commercial 3 here. Down here, same thing. We're going to assign them to commercial 1, commercial 2, and commercial 3. Now we know that men and women have different responses. So we're not going to compare men and women. We're going to take the 3 male groups and we're going to give their data to the people who are analyzing it, and they are going to compare that data. We are going to take the women's data and give them to the person who is doing the analysis, and that person is going to compare their data. So this is double blinding. The men and the women don't know what group they were assigned to, and they have no clue that the other groups are seeing different commercials. So all of that side of it is blinded. Then we are just going to have the groups labeled 1 through 6. So the people who are doing the analysis side of it, they will not know whether it's men or women, and so we will be able to know whether the genders go with the same. So we'll be able to say, oh, well, men prefer this commercial, but women prefer this. Because the people doing the analysis don't know what groups are men and what groups are women. Again, that's the concept of double blinding. Let's look at another experiment. So every experiment so far that we have done or designed has had one factor. Our gummy bears, the only factor was color. The tomato plants, the only factor was fertilizer. The vehicles, the only factor was gasoline. And this one most recently, the only factor on this was the commercials, because we separated the men and the women. So what happens when there is more than one factor that has more than one level? Sometimes it's important to have multiple factors because it will help us to examine what happens when factor levels are applied in different combinations. And so this is where it gets a little more tricky, and so I'm going to help you organize your thoughts when we have more than one factor. So we're going to talk about that OptiGrow fertilizer example again. We want to add a second factor. So this time, we're going to make changes to the water. We're going to add additional water to some of the plants. So we want to see if the combination of water and fertilizer makes the plants do better. So before you start figuring out how many tomato plants you need, how many groups you need to figure out how many different treatments are there going to be. So this is my little side work that we're going to talk about. Do a little side work over here. So what are the 2 things now that the plants are getting? The plants are getting fertilizer and they are getting water. So what were the levels originally for fertilizer? We had none, we had a half a dose, and we had a full dose. For water, all the plants have to get water. So 1 of the water is just normal water. But some of the plants now are going to get extra water or additional water. So to know how many treatment groups you have, you play connecting with all of the different options. So, and I'm going to use colors to help me out here. None is going to get paired with normal and extra. So that means that there's 2 groups there. Half a dose is going to get compared with normal and extra. So there's 2 more groups. And then finally, full is going to also go with normal and extra. How many lines are drawn there? There is a total of 6 lines. That means that we need 6 groups. So we now went from needing 30 tomato plants to now we need 60 if we were doing 10 per group. And so this little side work, you don't have to write this out, but this is my way of showing you how to mix more than one factor. So again, if you're looking for how the vocab ties into this, these 2 guys right here, these were your factors. These each here, these were your different levels. So the little markings are levels. Whoops, if I could spell right. And then when you combine them, the different colors, the color combinations, these are the treatments. So we now have 2 factors. One factor has 3 levels. The other factor has 2 levels. And our treatment is how many color combinations we have, which there are 6 treatments. So let's talk about diagramming it. We are going to start by randomly assigning 60 tomato plants into 6 groups. 1, 2, 3, 4, 5, 6. So this is group 1, group 2, group 3, group 4, group 5, and group 6. Each group is going to be assigned a treatment. Remember, that's the combination. So group 1, we are going to give no fertilizer and normal water. Group 2, I'm going to give no fertilizer, but they're going to get extra water. Group 3, they are going to get half of the fertilizer, but they're going to get normal water. Group 4 is going to get half fertilizer, but they're going to get extra water. Group 5 is going to get full fertilizer, but they're going to get normal water. Group 6 is going to get full fertilizer, and they are going to also get extra water. And we're going to treat the plants, and they're going to grow, and they're going to create tomatoes, and we're going to give them to the judges. The judges are not going to know what group got what. We're just going to ask them to try all 6 of these tomatoes and rate them all. And so then the judges are going to give us a rating scale, and we're going to bring all of the results from all of the groups back together, and we're going to compare the results to decide what's the best combination of fertilizer and water to get the best tomatoes. And so these are just experiments that had some extra pieces to them. So when you come to class, we're going to do more experiments with different levels so you can practice some of this side work that we use to figure out the different treatments.